Okay, let's work another fertilizer calculation with a little change to it from the last one. A lot of times, the problem is we get into, for example, doing part per million calculations where we're dealing with a milligram per liter, so it's metric. And then you may go buy stock tanks or have big storage tanks for your fertilizer that are gallons. And you've got to do this English metric thing. And really all it is, immediately we might look at that and go, I can't do this, I'm confused. But all you've got to do is do the English metric conversion. So let's say you're doing a trough system with herbs and vegetables or some kind of hydroponic system. So you've got a big, large stock tank. Let's don't call it a stock tank, sorry. Storage tank with your fertilizer solution. And that's going to go out to the crop and come back. So you're keeping this. And this is 5,000 gallons. Well, when we get into doing our solution calculations, the problem is we don't know gallons, we know liters. So in this scenario, what we simply can do is take the 5,000 gallon tank, and we know a gallon has 3.79 liters in it. So times 3.79 liters per gallon, gallons cancel out, and we come up with 18,950 liters. So it's an 18,950 liter stock tank. And now this is in liters, which we're used to doing with parts per million. So let's remember this and let's work this problem now. We have that stock tank, which is 5,000 gallons, or it's also 18,950 liters. And we want to make a solution. We want to use calcium nitrate. We can just buy that commercial source. And on the bag label we look, and this is a very common analysis for calcium nitrate. It turns out that particular calcium nitrate is 15.5% nitrogen. And we want that solution in the tank to be 100 ppm parts per million nitrogen. So how do we work this? Well, we go back to our beginning where we want 100 part per million nitrogen. We know by definition that that is simply 100 milligrams of nitrogen per liter. And we again, as we have before, divide that by the percent nitrogen that is in the fertilizer expressed as a decimal. So 15.5% expressed as a decimal, 0.155. Now again, for those of you that don't want to get bogged into the units, you just divide that. For those of you really interested in the units, that again would be 0.155 milligrams of nitrogen per milligram of the calcium nitrate. Anyway, when we divide these, of course, these cancel out, the units flip, but the 100 divided by the 0.155 should be 645 milligrams of the fertilizer, calcium nitrate, per liter. So all we did, definition of what a part per million is, so we knew how many milligrams of nitrogen per liter. We divided by the amount of nitrogen that's in the fertilizer expressed as a decimal in order to get it from how much nitrogen we need to how much fertilizer we need to measure out and put in there. And we come away with needing 645 milligrams of calcium nitrate per liter. And remember that stock tank was 18,950 liters. We would just simply multiply by this. And by the way, let me step back for just a minute and let's do it this way because I'm going to have a huge number here. 645 milligrams, divide that by 1,000 to convert that to grams. There's 1,000 milligrams in a gram. Let's make this number a little bit smaller so it doesn't get huge on us. So 0.645 milligrams calcium nitrate per liter, and then times the 18,950 liters, and you'll come away, whoops, sorry, that became grams when we divide it by 1,000, and that will come away being 12,222 grams calcium nitrate in that stock tank. So these liters cancel. So a total of 12,222 grams, or 12.22 kilograms of that fertilizer in the stock tank, brought up to that 5,000 gallon volume, and that would be a solution in there that would be providing 100 parts per million nitrogen.